Morning, everyone. Welcome to this introductory presentation about Coursevita. Coursevita is an innovative learning platform designed to provide flexible, high-quality education to learners worldwide. Our mission is to make learning accessible and manageable, even for the busiest individuals with a wide range of courses in various fields. There is something here for everyone. So let's dive in and see what makes Coursevita special. Before going in about Coursevita, today we have the pleasure of welcoming Vishwaja Reddy as our esteemed speaker. Vishwaja is currently working as a data scientist at Providence Global Center, where she applies her expertise to solve complex data challenges and drive innovation. With over 5 years of experience working for some most reputed multinational corporations, including Accenture, Vishwaja has a wealth of knowledge and experience in the field of data science. Her background includes working on various projects that have had significant impacts on the organizations she has been a part of, and we are thrilled to have her today to share her insights and experiences in data science. Please join me in welcoming Ms. Charity. Now, let us see why choose Course Vita. So, why should you choose Course Vita? Firstly, our courses are designed to fit into your busy schedule with learning flexible options. The bite-sized lessons make it easy to learn on the go, and also the downloadable materials ensure you can study offline whenever you have time. Additionally, our industry-recognized certificates can help boost your career prospects. Let's take a look at some of our success stories. Many learners have benefited from Coursera's programs, with testimonials highlighting significant career advancements and personal growth. These stories demonstrate the world impact of our courses and success of our learners have achieved. We've seen Nikita Verma from Yale University has quoted that Coursevita has a good selection of courses on various topics. Platform itself is user friendly and easy to navigate. I found the content quality to be good overall, but some courses could benefit from being more up to date with the latest industry trends. And also we have Anvita Chaudhary from we have Anvita Chaudhary from Accenture who quoted that Coursevita is a decent platform, especially if you're looking for some free introductory courses. She took a course on introduction to business management, and we are so glad that it has given a good starting point to her. And also, 8 out of 10 learners from Coursevita have quoted that they are so pleased with our courses. So, for your next step in your so if you're ready to take your next step in your learning journey, joining Coursevita is so easy. Simply sign up on our website and you'll have access to a wealth of resources and courses. We often have special offers and discounts, so be sure to check those out. If you have any questions or need assistance, our contact information is provided. For all sort of updates, please follow our social media pages on Instagram, LinkedIn, and YouTube so that you'll have an updated data structure course with every single week. We have a free workshop going on. So I hope to see you guys soon on Course Vita. Thank you, Trinath, and I pass this on to Vishwajar to take over.
Yeah. Good morning, everyone. Thank you for my introduction, Aditya. So, as you know, I'm Vishwaja, and I'm currently working as senior data scientist in an MNC. So, I have 5+ years of experience in data science, and I've been working as a data science tutor for more than 2 years. Over the years, I've worked in both marketing and healthcare business domains. So let's start today's session, data science architecture for basics. Let me share my screen. I hope my screen is visible.
Yes, Vishal.
Okay. So let's get into this. So the data science architecture for beginners. So agenda for today's workshop is what is data science? What are the components of data science and the life cycle of data science? You're going to learn the applications of data science and what would be the career if you choose a data science, and how can you become an expert in the data science, like what are the tools and languages we can use in the whole data science. We'll get to know. So what is data science? So data science is an area which involves the extraction of insights from the data. So it is also a data driven science. So data science is nothing but a data driven science which intends to analyze and understand the data. So you can also it also reveals the features from the different points. So you can use various scientific methods, algorithms, and process. All this whole structure becomes a data science. Let's deep dive into that. So why this popularity for AI? So what is the sudden demand for AI nowadays? So you can see the main reasons for the popularity of AI: data generation and more computing power and more effective algorithms are used day to day, and the broad investment. So let's understand why the data generation. Over the past years, if you compare today's data with the previous past data, so we have been generating tons of data day to day. So the amount of the consumption of data is increased and the usage of data is increased. So that's why we need to analyze the data by you, and we need to process the data using the machine algorithms. So that gives you the valuable insights which are helpful for the industries or like organization to grow. So that is the main reason. The data generation is a main reason for the demand of artificial intelligence. So more computing power. So nowadays, if you are trying to implement AI, so you can see the computation power has been increased rapidly. So you can understand the AI models are involving in high computational powers. And like to understand the large data and to solve the large data, we need something like neural networks and like complex AI algorithms. So that's why we are finally performing high level of computation powers and high level of complex algorithms. So that is the main reason again for the popularity of AI. So another thing is like effective algorithms. So if you compare the past with the given data directly, you can't solve the problems. You need to use more complex algorithms to solve it. So that's why deep learning, machine learning, and artificial intelligence are growing rapidly. So broad investments. So if you see the big giants like Tesla and Netflix and the social media things like Facebook and Instagram, everybody are into it, artificial intelligence. They are exploring many things using the artificial intelligence, and the demand is growing rapidly with broad investment. So let's understand what are the components of data science. So you can know. So the data is the oil for today's world. So if you use the right tools and technologies, and if you convert the data into the business understanding insights, you will gain a lot of things. Let's understand what is data science. So data science consisting of maths, like the mathematic concepts, the machine learning, the computer science techniques, the data processing, statistical research, and the domain expertise. Let's say the domain might be your marketing or like your healthcare or your financial domain or whichever the domain you are working. You need the data science becomes everything. So the data science tries to enable your fast and better decisions. So it also helps you to recommend the right product. Like if you are going to a shop and you are trying to purchase a product. So automatically, like using the decision, like data science algorithms, you can enable the better and fast decision, and you can recommend a right product for your according to your requirements and according to your past history. Let's say you are trying to, like, you want to watch movie in a Netflix. So by using your past data and like which genre of movie you want or like which type of action scenes or which hero you are preferred or like you like, based on those information, the movie is recommended. So all these recommendation systems, and you're predicting sales. Like let's say if you are saying price of this month is 50 rupees of a product, and you want to predict the price of same product for the next month or like next 6 months, then the data science helps you to predict the futuristic prices of that particular product. So what are the things we are using is like stats and the visualizations and the deep learnings. Let's understand what are the stats we can use, like what is the visualization we can use in the data science in next slides. Okay. So coming to the life cycle of data science. what is data science actually? So if you're trying to understand, let me give you an example. Let's say you are converting a problem statement, then the next step would be like discovering the data, data processing, model planning, and building the model. So let's say I'm taking an example of problem statement is like if you want to predict the house price of Hyderabad, like Hyderabad or any particular city. So what you can do is like first you will see like if you want to predict the price of an house. So this is a problem statement. And what you'll do, discovering the data. What are the data you need? Historical data. What is the historical data of this particular house? So you will see number of rooms of that particular house. What is the location? What is the construction year? And like, do you have any litigations of that particular building or like that area? So you will collect all the information of that particular house and you will note it. Then what you will do, data pre-processing. Then after collecting the data, you will try to analyze the data. You will try to see whether the any missing values are there in the data, and you'll try to clean the data. So after cleaning, after missing, if missing values are imputed, you will try to do the feature selection, and then you will do the analysis to get the model. So this one we can discuss in deep in the next examples. Okay. So the main steps involve like the business understanding of the particular problem, and you are trying to do a data mining. Data mining is nothing but collection, cleaning, transformation of the data. All these things comes under the data mining and data cleaning. Exploration is nothing but you're trying to visualize the data, like you're trying to explore the data through different perspectives, like in the using the chats, different chats, like you have bar charts, you have line charts. By using the different line and bar and box plots, all these things you can explore the data, and then you can do the feature engineering so that you can get the predictive model. So that gives you the ultimate what is the decision you got from the final output. So let's see applications of data science. So what are the applications of data science? So we are using data science in a day-to-day activities. Let's see, like if you want to travel. So if you want to travel to a particular place for the holiday destination, so what you'll do? So you'll try to book your flights, hotels, and you want to see the itinerary of that particular place. So if you want to see the dynamic prices, you can also use the data science models. So if you want to see the predicting the flight delay, like why the flights are delaying and what is the reason and what is the price of the ticket for your next travel. And all these things will comes under the DS again. So if you want to go to the marketing, if you see the marketing also, whether your product is upselling or like cross selling, or like whether the product of sales are going up or down, what is the process of that particular product in the whole life cycle, like in the whole life cycle of the marketing. And if you want to understand the life cycle, like lifetime value of a customer, predicting lifetime value of customer is nothing but what are the customer the what is the profit that particular customer is giving to your business. So let's say whether he is coming back to your shop again, or like whether he is buying the bulk amount of products. All this comes under predicting the lifetime value of a customer. This is the main thing which helps the marketing domains and retail domains to grow their market. So next, when you see the healthcare sector, nowadays in the healthcare sector, to predict the disease, like whether that particular person he has the heart attack or not, or like diabetes or not, and if you want to give him suggestions of medicines which they can use, or nowadays we are also having image classification. So image classification also, it tries to understand the image, like if you're giving an x-ray of your lung. So what it does is the algorithm try to understand the X-ray from the image itself, and it tries to give you the analysis, like whether he has the pneumonia or like TB or not, just by looking into the image. So that is the effective thing which we can use from the healthcare perspective. And there are rapidly increasing technologies in healthcare nowadays. And you can also see the sales. Again, the sales and the demand forecasting is same as a retail in the marketing. And the other thing in the automation. So if you see the automation, the self-driving cars, all these things are coming from the AI. So AI itself, if you give the algorithm or if you give the process, then automatically the car drives itself. So that is like a self-driving cars. Automation is useful for this. And the next one is like credit and insurance. If you see the banking projects, like if you want to understand whether the claims which they have, claims is nothing but if you, let's say, in an insurance company you already had a purchase, like already had some hospitalized, or like you have the billing, you will try to give the bill to claim your insurance. Then what happens, the insurance company is trying to use your claim and he'll find like whether you have submitted all the claims or not, like all the documents or not. And all these things also, instead of using the all manual process, we are nowadays we are automating the process. Just by the machine learning algorithms, it tries to predict whether your claim is like a fraudulent or like a correct claim. So for the insurance company, it is very useful to understand whether it is like fraudulent, or it is like normal, correct. So these are the applications which we are using in a day-to-day life. So let's understand what are the careers we have in a data science. So the most prominent data science jobs are nowadays the data scientist, the data engineers, data analyst, machine learning engineer, deep learning engineer, and the business analyst. So let's understand why the data science is booming nowadays. What data scientists do is like they try to recommend what sort of data you need for the day-to-day activity, what sort of data you need for that particular business to grow. Like you are trying to build the machine learning models, you're trying to scale their efforts into your large models, which helps to optimize the running process. So now let's understand the data science. What does data, if you see the data scientist, so he'll try to examine which questions you need for the answers. Let's say which, sorry, do anyone have the doubts? Okay, should I continue? Okay, let's come back. So nowadays, the businesses are using the data scientists to source, to manage, and to analyze the large amount of the data. So, what, like, if you want to become a data scientist, so what are the skills you need? So, let's see here. What are the programming languages you need to become a data scientist? So, the mainly, if you want to know the programming, you need the Python or R for writing the script. And the data visualization, such as like Power BI and Tableau or like QuickSense, which helps the data visual, like you can understand by using the chats. So these are the data visualization tools and the programming tools which you need for a data scientist. And you also need to understand the concept of machine learning, and to extract the data you need to write SQL queries also. So you should understand the statistical concepts. Machine learning, data wrangling is nothing but if you want to extract the data, you are using the SQL, Snowflake, and all this tools to extract the data from the different data lakes. So these are the skills which you need for a data scientist. So again, let's see what does data engineering do. So data engineers try to manage the large amount of the data, which is rapidly changing. So day to day, we are saying that day to day the data is changing. The incoming flow of data rapidly increases. Sometimes you will not have any flow of the data. To manage all these things, the data engineer plays a key role for this. So they'll try to focus on developing the data, deploying, and managing the data. So they'll try to build the data pipelines, infrastructure, so that they monitor the free flow of the data. So if you want to become a data engineer, you need to have the programming language, like again, like if you want SQL, Snowflake, and like you need to connect this data to the visualization tools like Power BI or like Tableau. So the programming tools, the data visualization is must and should if you want to become a data engineer. So again, the data flows, everything, you need to be good in SQL and Snowflake for data engineer mostly. For data scientists, you just understand the SQL queries, then it is enough. But you need to have full grip on machine learning and Python for data scientists. So when it comes to a data analyst, so what data analysts do is like he will become a bridge between the data scientist and the business analyst. Let's say business analyst is a person who understands the business and he'll try to give that insights to a technical person. So this guy is like business and he'll understand bit of technical perspective. So now data analyst will be a bridge between the data scientist and the business analyst. So they'll try to organize, analyze the data, and they'll try to give you the insights from it in a business perspective. So if you want to become a data analyst, so data analyst is also a major role. Like this is also rapidly growing career in the data science. So he'll try to like you should understand the basics of programming, like all programming languages, whether it may be a Python or R, or like if you are using the visualizations, the Power BI is must for data visual, like in the data visualization you can be like anything, Power BI or Tableau, or you need to have the Excel perfect, like you need to have the good Excel skills and you need to understand the stats and a basics of SQL and machine learning is important for data analysis. So by this diagram you can understand like what are the key skills needed for each job role. So if you see the machine learning engineer, so he need to understand. If it is like ML engineer, you need to be more flexible with the programming language. If you see in all careers, the most common thing is like programming tools and like the data visualization. So if you are going through with the Python or like R or any programming language, that helps you easier in the data science. So let's see how you can become an expert in data science. So what are the key skills you needed for the to become an expert? So let's say from the basics, if you want to understand the data science, you need to have the strong foundation of mathematics and statistics. So if you're saying, okay, I'm so and so, I'm not from the math background, I'm not from MPC, I'm from a different career. But still, here we are using the statistics. So statistics is very easy to understand. If you don't have any strong foundation of basic maths also, it's okay, you can understand the statistics and you can use it for the again you can start your career. So it's not like only MPC or like it's not like whoever having the maths background. So you can learn the stats. It is very easy to learn the stats and maths, you can understand. But but this is the strong foundation for the data science. Like if you want to build any machine learning algorithm, so the key to understand is like the equations will become like you should have the basic equations of the statistics. Then only you can understand the root cause analysis of machine learning. So maths, machine learning, and still further, if you want to deep dive into machine learning, you can use the deep learning techniques. So let's understand like what are the concepts we can use in the mathematics and statistics. So if you see the mathematics and statistics, you should understand the basics of linear algebra, calculus, statistics, and probability. So in linear algebra, mostly we are trying to focus on like vectors and matrix and like what are the key operations which we can do with vectors and algebra. So here in the calculus also, it's like you need to understand the functions, log losses, cost laws, and like the basic functions. It's not like too deep, but it's like a basic level of calculus and linear algebra. But you need to understand the whole concepts of statistics and probability. So here are the statistics which helps us to analyze and visualize the data. So if you want to go deep into the data and if you want to see how the data is flowing, like how different patterns are coming, you should understand the statistics. And then only you can, like first, if you know the basics also, it's okay. You can do the modeling. But when you do the modeling of machine learning, and if you get any problem in after doing the modeling and deploying, then to understand the root cause, you should have this maths background, like statistics foundations. So that's why it is better to start your career by understanding the statistics first, then going into the machine learning, and then going into the deep learning and AI and so on. So first thing you need to learn is statistics. This is very important. And the probability, like you can understand the partial probability, it's enough. And probability also to understand the p value, and if you want to see the p value and all these things, probability value, or like how the random variables are going and how the distributions are going, all these things, the expected value, the actual value, and how it is varying, you can understand by the probability. In statistics, mainly we are focusing on something like null hypothesis, alternate hypothesis, how the null hypothesis rejected, or like how we are rejecting the null hypothesis and accepting the alternate hypothesis. And you can also sometimes use like t-test to understand what is mean, median, and all these things comes under the statistics. So that's why I'm saying that statistics is a key for data science. So let's understand the tools and languages which we are using for the whole machine learning and deep learning. So if you see the tools, the top 20 technique, like top 20 skills in the data scientist are like, we are using mostly Python, then comes the R, and then comes the SQL. So you can understand, like Python is like a general purpose language. Okay, see, Python is a general purpose language, and Python is made the more complex data into like easy. Like you can layman also can understand the Python coding, and they can solve the most complex AI, ML, and deep learning things. Why we are using Python is like you have less coding. So instead of writing in C programming or Java, if you write some thousand codes of lines in Python, you can minimize all the codes and you can write everything in like 1 2 lines. Let's say if you are using some 10 lines in C, same thing you can get in 2 lines in Python. So, and Python is less coded, and this platform is very independent to use. And here you have pre-built libraries, like you have something like Pandas, NumPy, and you have all the visualizations like Seaborn, Matplotlib. Like you can visualize here, you can extract, like you can load the data, you can do analysis, you can do different things in Python. So that's why it is easy for the development and like deployment. So let's understand what are the again like different tools. Is it only Python? No. You need to understand like if you can use like Python or R. Like most of the companies nowadays using shifting towards Python, because like again the R is so complex to understand. But if you want something mathematically, like if you want to understand the statistical concepts and if you want to know deep dive into analysis, you can use R. But Python, whereas in Python, it's if you have, it's not like you have too much of mathematics. You can, it is like normal general purpose, but this is like mostly used for the statistical tool. So, like previously, like before past 5 years, most of the companies are using R. Nowadays, this R is also shifted to Python. So, the scripting language R is also shifted to Python nowadays. And SQL. So, as I said, like if you want to extract the data from any data lake, nowadays we are using Azure services or like Amazon Web Services, or like, in the Amazon, you have something like Redshift. To extract the data, you should write something SQL queries, like SQL queries, and then you can get the data. For getting the data, for manipulation, for transforming the data, you are using the SQL. Excuse me. So now if you want to understand the visualizations, so if you want to know how the data is varying and you want to see the data, like exploratory data, you can use the dashboard such as Power BI and the Tableau. Tableau is like it is bit pricey compared to Power BI. Power BI is like Microsoft tool, which is like you have some free versions also you can try in the Power BI. It is easy to understand compared to Tableau, but both has again same functionalities. It gives you the uh, data visualization. What Tableau does is like it can hold up to a large amount of data compared to Power BI. That's why like a few companies still use the Tableau and like they prefer Tableau with the licensed version. And few companies, if they are using under the less amount of the data and they want something like again from connecting from URL to URL, they use like this Power BI. Yeah. So like if you have any doubts, like we can discuss in the last 30 minutes. So keep your Q&A ready. Like now, let's understand what is artificial intelligence, what is machine learning, and what is deep learning. So AI is a like artificial intelligence is a technique which enables the machine to mimic as a human behavior. So if you want to use instead of a human, you are trying to replicate some machine which you are giving the same all the requirements of that particular work, then machines are trying to learn the algorithm or like machines are trying to understand the flow of work and then they are trying to do. So in the artificial intelligence itself, you have something like machine learning, and in a machine learning, if you deep dive into ML, you will have the deep learning. So the subset of AI, nothing but machine learning, and the machine learning has all the statistical techniques, like you are using maths to improve the like to enable the machines to improve the experience of that particular process. So let's understand what is deep learning and machine learning in detail. So what is deep learning? So you're seeing nowadays a deep learning is like booming thing. Why? Because due to again the same reason, the day to day the data is increasing, and to understand that particular complex data, that huge data, we are trying to improve the machine learning, and that becomes like your deep learning. And deep learning is again the branch of machine learning which is based upon all the sets of algorithms which has the high end model. Like if you want to understand high level of data, if you want to solve complex complex algorithms, you are using DL. In that, you nowadays DL is nothing but it is almost, you can see this is the structure of neural networks. Neural networks is like function of human nervous system. Like here we are trying to involve, like it is connecting one cell to other cells and other cells to other cells. You are trying to multiply the cells and you are trying to interconnect the computational units and you are trying to process the data. See, if you understand, like if you want to understand types of deep learning, so we have something like ANN, CNN, RNN. That is nothing but artificial neural networks and multi-layer perceptrons and convolution neural networks and recurrent neural networks. Again, this is like a high-end one. Like if you want to understand what is perceptron or like forward feeding, feed forward or like feed backward, all this encoders, decoders, and VAE or all this comes in the high level of the data, like high level of the deep learning. So you should understand, if you are familiar with the machine learning, all concepts, then the next step would be like a deep learning. So this is about all about the deep learning overview. And now let's deep dive into machine learning. What is the structure of, like what is the whole structure, whole process of machine learning? We can understand. Okay. Machine learning is the most popular technique of predicting the future. So by using your past or like your previous values, you're trying to predict the future values, and you will trying to predict the future decisions with the existing data. So what does this machine learning algorithm do? So you're trying to train the model, train the with the given data, you're trying to train by using the different algorithms, and then you're giving the model like to analyze. So the whole process is like a machine learning. So let's see what are the, just now I told you the applications of machine learning are, let's say, if the basic thing is like day to day you're getting emails. So if you want to understand whether this email is spam or not, so if you want to classify something, you're saying yes or no, this is correct one, this is wrong one, what you can do, you can use something like classification model. And that, just like by using that classification model, what it does is like it separates your whole, like if you send 100 of mails, by taking that 100 mails, it tries to use that particular algorithm, and it says like these are spam mails and these are correct mails. So that is like, that is the function of the machine learning like ML model. Now if you see machine learning, mm, okay, types of machine learning. So you have something like supervised learning, unsupervised learning, reinforcement learning. So what are this supervised, unsupervised, and reinforcement? Let's understand step by step. One second. So supervised learning. So supervised learning is nothing but, so here you have all the label data. Let's understand supervised first. Supervised machine learning is nothing but it's a branch of artificial intelligence that focus on training models to make your predictions based upon the whichever the data you have. Let's say this is the data you have. This is a bunch of vegetables. So this particular data, I'm not giving anything. You are just directly giving this data, whole data to the model, and you are also saying you are also giving another thing like this red color is tomato, orange is carrot, and green is like bell pepper. So here you're passing the labels, and from the other side, like again, you're saying just this is the data first. Then for the training model, you're giving the labels. What it does is it will try to understand the data, it will try to give the labels, and it gives the output as like, okay, this orange is carrot. Like these are the, like you have three carrots and you have three tomatoes, three bell peppers. So it will like, this is mostly like you have something labeled data. So in the labeled data, you are giving the inputs and it will give you your outputs. That is supervised. And in the supervised also, we have something like classification. Like if you further deep drill down, you will understand two types of supervised learning, that is like classification model and the regression model. Let's see what is classification and what is regression. Okay, so this is like this, these are the types of supervised. So supervised is nothing but you have the label data and you are giving the input with the labels, and then it is giving you the output. Now in this, let's say what is regression and classification. So regression is nothing but if you have something continuous numerical numbers. Let's say you are asking what will be the temperature of tomorrow. So now you can, like you are asking the model with this, and it will try to give you something like 84 degrees or like 41 degrees Celsius, or like you are giving some numerical number. Whereas classification is nothing but from the whole data, like from the whole information, you're saying whether will it be hot or cold. So you're classifying the data. So the output will be like yes or no, or like you're saying hot or cold. You're classifying something. What you will say, how is the weather? It is hot or it is cold. So whereas in regressions, you have the numerical data. So you have something continuous variables, whereas here you have classification. Let's say if you have deceased or not deceased. So it is like the output will give you the categorical form. And whereas in regression, the output is like common, you will get a number numeric form. Let's again deeply understand what is supervised. So here what you're saying in the regression, you have something like linear regression models, polynomial regression models. So all these things uses the continuous numerical numbers. You can also use machine learning models like decision tree. All these things we can deep dive further. But as of now, I'm telling which are like which comes under regression, which comes under classification. So the decision tree, random forest, classification, all these things comes under the supervised learning. Now let's understand what is unsupervised learning. So unsupervised learning is nothing but same. Like if you're like similar lines, you're saying like unsupervised is a type of machine learning model which the algorithm learns from unlabeled data. Let's say you're giving an input, you don't have any labels of it, just you're directly dumping the data input, and you are asking machine itself, you try to interpret and you try to give your algorithm and just give me the output. So here, as in supervised, we have something like carrots or like onions or brinjal separately. You have the names. Here we don't have names. Then what machine learning does is like here the algorithms understand the data and it will try to separate. Okay, the sizes are same, the shape is same. So that's why it is grouping into this one particular onions, or it will not give any names, but it is saying like this is some particular category, this is one group, this is one group. Here it is not seeing a color, but see, you can see the shape and you can see the size, then it is classifying. So it is grouping the whole data. Basically it is understanding the data and it is trying to group the data. So that is nothing but it becomes like you have something like clusters or like association problems with the unsupervised learning. So if you understand the unsupervised learning, you have something like clustering and association analysis. Let's say what is clustering? Clustering is nothing but you want to discover some groups. Like here also, this is a basic clustering model. Okay? So it is trying to grouping the outputs. So it will group the similar kind of things. So you have, let's say, in a school, there are lot of like you have 1,000 people. If you want, like you directly gave the 1,000 people. So what machine learning does is like it will take the information. Let's say they are under like first class, second class, third class, or like if they are from same color dress, it will classify into one particular group. If you see from the height, they'll all these height people will be categorized into one group, or the people from the same region will be categorized into one group. So it is nothing but you're grouping the whole data instead of the labeling. Like if you have labels, what happens is like if you give the school data, it will convert into like it will group as first class into one segment, second class, third class, fourth class. It will divide into class wise because you have this person belongs to first class, this person belongs to second class. You have that labels and supervised, whereas in unsupervised you don't have any labels, just that machine learning algorithm understand the data and it will give you the output. So that is about unsupervised learning. And if you try to understand the semi-supervised or reinforcement learning, this is nothing but it has the combination of both labeled data and unlabeled data. So let's say you have the large amount of data. Few things are labeled, like you're giving few things are labeled and few things are not labeled. Then what does this machine learning understands the like semi-labeled data and it will try to process using the machine learning models. So some few things which are unlabeled becomes a grouped and which are labeled will give you the labels. So if you try to see the basic difference between all processes, you're saying here it takes the inputs and matches with the output to give you the target function. What unsupervised does is like it takes all the inputs and create you the model and gives the output. So here semi-supervised is nothing but it is combining both. So you can see the classification and regression models and supervised, clustering and association models and unsupervised. And you have both combination of classification, maybe clustering, both kind of things. Like all these combinations will be in a semi-supervised. So like these are the basic examples which are coming from the supervised, semi-supervised. And like, yeah. So now let's understand this is the types of machine learning. Now let's understand the flow. How machine learning flow, like what is the whole process of machine learning, like what does the real time world is doing and all these things. Let's get into that. Okay. I hope till here everybody is clear. Like stop me, like if you have any questions also you can ping in the chat box. I can answer your questions. So again, yeah, let's come to the machine learning workflow diagram. So let's say you have again will go to the same problem statements. Like if you want to predict the price of a house using the past data, so that is your problem statement. And what you are doing, you'll try first step would be you're trying to collect the data. So let's say what is a collection of data? First, data collection is nothing but so you can collect in a different types. Like say let's say you have something like different data sources. You have structured data source, like unstructured data source, your primary data collection. See, data collection is nothing but the process of collecting and evaluating the information from different sources. Let's say in the primary data, what you can do is like basic surveys. So you can collect the data from the surveys, the questionnaires, and let's say interviews. Like interview, you can give that questions and answers, observations and experiments. From all these things, you can collect the primary data. If you go into the secondary data is nothing but already existing data. Like if you want to collect some like if you want to collect from some published sources, or you want to collect something from the online database, or like any records, or like past research data. This is nothing but the secondary data. Or like again, all third party data also you can collect. By you have different types of data sources where you can extract the data. So let's say here, if you want to understand research analysis and decision making in all, let's say I'm saying in terms of business domains, if you go to the healthcare, if you go to the marketing, you're getting something like feedback, you're getting something like reviews, rate my company, rate my hospital, and all these things. So you will try to collect from that particular information from all the sources. And then in the real time data nowadays we are using something like Snowflake, and Amazon services are using the Redshift to take you know to retrieve the data. So first what you are doing, you are trying to retrieve the data from all the sources. These are the data lakes, and you are trying to take the data. To retrieve the data, you are using some SQL codes, or PySpark codes, so that you are trying and transforming from this lake to your model. Like let's say from the whole lake, you want only I want this particular area data. What you do, I'll take that particular area of data only. Then the next step, what after collecting the data, what you should do is like you have to pre-process, like process the data and clean the data. For processing and the cleaning the data, what you can do is like you have something like data exploration. So let's say we'll also start with an example. So as we are discussing, this is the house price, Boston house price prediction. So here I have something like all the details. Let's say this is the name of the house and who is the host, like whether he is confirmed or not. like whether he's like verified person, verified owner, or like unverified, the host name, and the neighbor place where they are using. These are the basic details. And you also have how many rooms you have for this, and which is a country, like where the location of that particular latitude, longitude. And you have the price, construction year, and you can also have something like house rules and reviews also, like the previous person gave the reviews and rules available. So this is like a whole data set. First you have collected all the data set. So first step is like data collection is done. So next, what is next? So you will understand, like after seeing the data, what I'll do. So let's say now if I want to understand here, if I'm seeing, I'll check whether I have whole clean data or not. Now I'm seeing like I have the blanks also. How many blanks? Let's say if I have some 1,000, if you have 200 blanks, then what you need to do with that missing one? So here you have missing. Blanks is nothing but the data is missing here. So for that, we have something like uh, data exploration. So data exploration is nothing but you will try to understand the data in depth. Let's say as of now we saw like what are the variables you have in that and what are the missing values. Missing values are like in a different types. Let's say if that particular owner name is missing. Okay, for my model prediction, I don't want that owner name. Like I just want whether it is verified or not. So what I'll do, if I want to fill the data which is needed for my model, I don't want unnecessary data. So what I'll do, I'll remove the unnecessary columns and I'll try to fill the columns which are needed only. So that is like variable identification, univariant analysis, bivariant data cleaning, and feature engine. So here cleaning, removing duplicates is nothing but removing duplicates, looking for outliers, dealing for missing value. Let's go here and let's see. Okay. Now here I have all the values as I told you. So here I have something 25 number of. So for my model, I don't want this ID, name, or like what are the main things which I needed, whether the host verified or not. So that means it is not a fraud one. Like you can trust this variable. Okay, this is good. Then you're saying the, if you say neighbor group, how the neighbors are affecting my price of that particular. So if you can say like if your neighbors are slum area, so the area is slum and your uh, people around you who are also poor, that means the price of that particular house might decrease. But if you are saying like every rich people are living in my neighbor, that means you are saying that automatically depending, that is influencing your price variable. So you are saying this price is a main thing. The main thing, this is the target variable because you are trying to find what is the future price of next 2 months. So this is the main target variable. And now you have to understand what are the other variables which are influencing this target variable. So I can say by number of rooms. So this is also one particular thing which can, these are independent variables, this is depending variable. So now I'm saying this number of room types, independent variable that is affecting my target variable, which is price. Okay. So construction year is also important for me. So then what I'll do, I'll also take this. Then number of reviews to understand. Still, like if you have less number of reviews, then you can decrease the price. So again, house rules and license. This is also again important factor. Area, main thing. Whether what is the location of particular house, that is also main. So this will become your target, and this yellow lines are like independent, and this is dependent. So now In the data cleaning, what I do usually is like I can remove the unnecessary data and I can keep only which are necessary. Now I said necessary is nothing but you want something like independent variables and dependent variables. So I'll try to remove the other things. And if let's say room type is missing, like number of rooms are missing, because that is an independent, that is an important factor for me to consider. So what I'll do, I'll go here. Okay, let's see the construction here. In this also, you are saying there are few blanks. So you don't have the complete data, you have blanks. Then what you can do, you can use something like median. So mode. So this is like continuous variables. So you can use something like mode. Mode is nothing but which is frequently occurring variable. So like that you can give mean. Mean is nothing but average value. Let's say you can give average of ratings. Let's say a number of reviews. So number of reviews is also an important factor. And if you have any missing values and you want to fill that missing values, what you can do, like let's say you have 10 variables in that 8 are filled and 2 are not filled. Then if you want like 9 are filled and 1 is not filled, what you will do, you will take the average of 9 and you will give that average value to the missing. So that is nothing but mean imputations. So these are the methods which we can use to clean the data and transform the data. So if something is like duplicated, what you'll do, you'll try to remove the duplicates. You will also check outliers. You'll try to fill the missing values. Just now I told the few missing value techniques. Let's also see outliers. So let's say missing values, you say dropping missing values. And I said like which are important you are considering, which are not important, you'll try to remove. And imputation is nothing but in that mean mode cases, you can replace those missing values. Another thing is nothing but outliers. Let's say outlier, the basic example. What is outlier? Suppose you are trying to observe the data, you're trying to analyze the data, and every data point, like most of the data points are going into certain direction, and but only few 2 3 things are going outside the box, or like it is going in a different direction. So you can see observation point that is distant from the other. So here are the data points, all these points are going into one direction, and this is one outlier. Outlier is nothing but you might have the extreme value, or you might have extreme low or extreme high values. So that extreme low and high, let's say if you are taking some sales value, sales of a product. In COVID case, what happened? The sales rapidly fell. So you are saying that object is like every time you are saying 100 rupees in all the last 3 years. But in COVID year, what happened? It was drastically went down into 10 rupees. So everything is like 100, 90, 80 at around this points, but it went to 10. 10 is like an extreme outlier. So if you want to do any other modeling techniques, this outliers, what it will, it will distract the model and it will give you the wrong results. Mostly in like if you see the logistic regression or SVM, this or other modeling techniques also, if you are having the outliers in the data, it will directly give you the wrong interpretations. So to avoid all those things, what you can do is like outlier analysis and outlier detections. So by using like you have different techniques to identify the outliers, and you should overcome the outliers also. You have different techniques. So what are the common causes of outliers? You can see here we have a list. Let's say the whenever you are entering the data, human errors or like instrumental errors or like the pre-processing, like or intentionally, or like you I said like natural disaster is like COVID, that is like again natural one. So any errors might cause to your outliers. So it is important step to analyze the data, to understand outliers and missing values. So here are the checklist of the data cleaning process. So up to date. So if you are checking a whole data, let's say day to day, week wise, or month wise, or yearly, you should understand like whether the data is up to date or like the dates are any mismatching. You should understand that up to date data and missing values. Like you should count like whether any missing values are there. Like just now I told you like if out of 1,000, 100 are missing, why 100 are missing, you should do the missing value imputations, numerical outliers, and removing duplicates. These are the main things. Again, like filling and all those things are coming next. But for the cleaning, you should not have any missing values. You should not have any duplicates. Let's say, what happens if you have the duplicates? Instead of 100, you're giving like 120. In that 120, if suppose if you have any outlier, what happens? So you should get the accuracy of 90%, but it will turn to extreme 100%, or like, you have some data fluctuations. So again, you will, after doing the algorithm, pre-processing everything, at the end, if you see the accuracy, you can't understand like what happened to my model, why it is giving this much high accuracy. First only you should check the data. See, if you want to come back and if you want to do the reverse engineering, that becomes a difficult task, right? After getting the output, you will have lot of reasons to get the that much accuracy. So that's why in the beginning itself you have to clean and you have to impute correct values. And the next thing is like you are doing the EDA part. EDA is nothing but you are trying to use all the visualization charts to understand the how data is flowing. So to summarize the main characteristics and to perform the initial investigations, like if you have outliers also you can get from the box plot or like histogram. You by using the different charts you are doing the EDA process. So for the EDA, you can use basic Python or like, Python. By using in Python, you have matplotlib or like Seaborn. By Python itself, you can get all the visuals. Otherwise, you can use the visualization tools like Power BI and Tableau. So this is the after like the data is ready. Now what is next? Now you are saying the feature engineering. Feature engineering is nothing but, let's say I'll go to that example. Here what happened, like now I'm saying you can see this rating values are like if you are rating something between 0 to 100, what is this number? So these numbers are between 0 to 100. This is like a different scale, and like this is like a different scale. This is a different scale. Like you have everything is not standard. So one thing is like you're giving 0 to 10 only. One thing is like you have a categorical variable, you have numerical variable, and you have something like name. Like it is not a numerical also. You have the text format. So how can you compare this text format or something, the data, limited data, or like every standard of the data is different. The every data type is different. Then what you need to do is nothing but feature engineering. What is this feature engineering? So as you saw, like you are taking only 10 variables, and that 10 variables also having the different data types. First, you need to understand the data. Feature engineering is a process of extracting and organizing the important features. So from all the raw features you are taking, like which are important, and you are trying to fit into the machine learning models. So here it will try after analyzing, after missing, like handling missing values, encoding the data. Encoding is nothing but, let's say, just now we saw like owner. In the owner data, we have he is like verified or not. So instead of giving that text verified or not, we can convert that text into one and zero. So one is nothing but verified person, unverified is nothing but zero. Why we are doing numerical? Because every other data format is numerical. The price is in numbers, or like rating is in number. All the numbers you have, other things are in numbers. but few things are text. So that's why you're trying to encode the data and you're giving like 1 0 or -1 1 0. So you're just categorizing, not giving 1 2 3 4 random numbers, just you're doing 1 0 type of binary digits. And here you're trying to so these are the basic techniques of feature engineering, which are normalizing and standardizing. Let's say, what is normalizing? This is the actual data. You have various scales of data, and the algorithm you using does not make any assumptions about the data. So if you give this random data, the model will not give you any correct accuracy. If you bring everything into a certain limit, like after normalization, it gives you something like everything comes under the same box. Let's say these are like out of the box, something it's our variables are going in a different directions. You're trying to put everything into a standard scaling. So you have a formula for that normalization and standardization. Also you have different formula that will standardize all the that will reduce all the minimum errors and maximum errors and brings into the standard. So this is the actual data. After normalizing, the data will become in a particular correct direction. So now you have cleaning, EDA is done, normalization is done. Like now the data is ready to go for the model. So let's see what are the next steps comes for us. Here, so here retrieving is done, cleaning is done, EDA part is done. You now preparation and transforming. Here you are doing the whichever the normalizing or feature scaling, standardization things are done. Now what you'll do, you will try and develop and train the model. How you the next steps are like how you are developing the model, how you are evaluating. After evaluating, you will try to deploy the model and you'll try to monitor. This is the basic flow. Now let's understand like what is training the model and what is developing the model. So training is nothing but, let's say this is a full data set. Just now I showed you, you have, let's say, 1,000 variables. In this 1,000 variables, full data set, you are splitting into X and Y variable. What is X? X is nothing but 80% of the data is an X and 20% is nothing but Y. So you are saying training, you want to train 80% of the data and you want to test out of 100, you want to test the 20% of data. So for the training, you are saying 80% and testing 20%. So from the 1,000, you're taking 800 points here, like 800 data sets here, 800 data points, when 200 data points for the testing. So then you are doing separate splitting of train and test. Then you are giving into the machine learning models. Like machine learning models, nothing but like here you can understand if the data is categorical, classifying something, you will give the classification models. So in the classification, as you saw, like you have logistic regression, SVM, and you also have random forest, decision tree, and all these things. You are giving those algorithms. Let's say if the data is like a regression, numerical numbers, you are giving the basic linear regression and KNN and all these things. So after the split, you can understand you are giving the machine learning models, whichever the models are used for this particular. You can't give some random, like here you have numerical numbers, and if you give the like logistic regression or like classification, and the output also you will get some different accuracy. So that's why you should understand the whole data. Then only you can give which model, like which algorithm is better for this. Then you will get the model predicts the test data and train data, and it will try to give you the predicted values. So let's understand. So here, what is the final step? Let's say you have actual values of 10, 20. So after this whole process, you are getting the predicted values or like 12 or 15. Let's say your actual values become 10 and your predicted is 12, then that means your model is giving at the good level, like it is being in a same line. If you're saying your real value, your actual value is 10, and you got something around of 200, that means whatever the model or whatever the data process you did, there might be any mistakes. So you should understand, like, after, like, you should understand the data, you should pre-process correctly, then only the model deployment, everything goes well. Sorry, model and like developing of the data goes well. Here, to understand um, the model, you are getting something like accuracy, precision. What is again accuracy and what is this confusion matrix? Let's see. Before that, I'll also give you an example. Let's say whichever the data I'm showing, let's show in terms of, so here we are using the Python, and here you're loading the data in Python. Then what you're doing, you're trying to understand the data, which are target variables, like which is independent and dependent variables. So same data set which I showed you here. This is the data set, and you're trying to understand what how many data points are there, like what how many rows, how many columns, and you're doing all the data pre-processing steps. So whether you have null values, is null, like is null is nothing but any missing values you can find. Again, you're doing EDA process. So in EDA you can use the different plots, as I said. So to understand the outliers again. So to understand the correlation between, you're using the correlation map. So if you see here, let's say here 91%. So that means the tax and the radius. Let's say the radius is nothing but the space, the area. If the area is more number, more taxes given. So that is like a good correlation. So if you have more area, more taxes there. So like that, you can understand the correlation of all the variables by using the correlation matrix. So this is part of EDM. After understanding, so like if you see the correlation also here, this is an important step, because let's say if you want to improve the, like if you want to increase one variable, it should not affect the other variable. So first only you will identify which are more correlated and which are less correlated, then you can take the next steps. So that is easy for you to understand, like which variable is impacting the other variable. Now here what you're doing, again, this is like a EDA part. After doing all the EDA, here I'm doing like XY split. X is nothing but whichever the target variable you are taking. Okay. So these are the independent variables, and this is like a dependent variable. So your X and Y are price you are taking as a Y, and not all other columns except the price you are taking into a different X. So that's why you're splitting into X and Y. You are dividing the independent and dependent. Then you're performing the model train and test splits are done. After this, you are performing, like here the model is numerical. That's why you're saying regression, and you're using the linear regression. And you're saying in the model evaluation, because it, as these are like a numerical numbers and linear regression, you are looking into the accuracy, R square, and like root mean squares, this kind of stuff. So now let's see here, if you get the what is this accuracy. The main thing is like to understand the accuracy, how the accuracy is varying and all. Let's see confusion matrix. Now, so if you want to get that accuracy, you need to understand. See, these are the actual values. These are the predicted values. Predicted and actual is nothing but, let's say in a hospital, you have actual values are like this person is deceased. Your predicted value is also saying like, okay, this guy is deceased. That means a true positive case. Your actual value is saying this condition and your predicted is also saying same condition. That becomes a true positive thing. Number of outcomes that are actually positive and you predicted the positive. Let's say true negative is nothing but you're saying this guy is deceased and your predicted value is also saying, okay, this guy is deceased. That means actually negative and your prediction is also negative. So both cases are okay. Your actual value is you are matching with your actual and predicted values. But you have something errors, like if you are saying this person is a healthy person. This person is healthy and you are trying to predict this person is diagnosed with some disease, so then that becomes a type 1 error. Here you are saying the healthy people are diagnosed with some disease. That means for the correct person you are giving the wrong prediction. Sorry, here for the correct person you're giving the wrong prediction. Here actually he is negative, actually he has some disease, but you are saying no, he don't have any disease. That is again a type 1 error, because where he already have the disease, and if you say he don't have the disease, then he'll not take the proper medication and he'll feel more sick. So that is a severe case. So this is the type 1 and this is type 2. Type 2 is nothing but like you're actually he's diseased, but you are saying okay he's not, but still somehow he can get back. But here because he's already good, and if you say the like here he'll take extra medication, but this is a crucial one. You are saying for a deceased person you are not deceased, so he'll ignore it. So type 1 error is like you need to check type 1 error every time. That gives, if this is wrong then the entire prediction goes wrong. So that is about your false positive and false negative. The combination, the matrix form of all the correct numbers and the wrong, like incorrect prediction, makes a confusion matrix. Now, what happens with this confusion matrix? You are going to identify the accuracy, precision, recall, F1 score, and again the log loss and all these things. So, lastly, let's understand what is accuracy. The basic metrics of the confusion matrix is accuracy, and here it measures the performance of the model. It will measure what is the correct, you are saying true positive plus true positive to the total samples. That means you are saying the ratio of all the true instance with the total number of samples you have. That gives you a correct accuracy. Whereas in precision, you are saying how accurate the model predicts the positive ones, like how the positive predictions are. You're taking only positive to the whole positives. So number of true positives to the whole positives gives your predictions. Whereas in recall, it is saying like what is the effectiveness of classification model to identify the true instance to the whole. Again, you are saying the sum of true positive and false negative. So these three are the important cases to get your metric, like to understand the whole model's whole output. So if these things are going wrong, then the model has something, like you have some errors. So like let's say if it is like 95, 92, 93. So all these three metrics are important for us to evaluate whether your model is going in a correct direction or not. Again, F1 score is the combination of, like it is a harmonic mean of precision and recall. So this three metrics and F1 score are like important thing to understand the whole problem. So I'll show you the example back. Okay. So this is also again classic example, iris data set. Same. The data pre-processing, everything is done, data visualizations are done, XY split is done, and then you are taking training, testing, and here you're trying to understand, you're trying to predict the models, let's say this is 93% accuracy. So here you say accuracy is 93, then okay, that is good. If it is going beyond 98, 100%, 100% accuracy is not like in the ideal model, also, it is like the model is something overfitted or underfitted. So by accuracy, by all these metrics, you can understand the model. So that is all about the machine learning concepts. And now let's try to conclude the session. So why the data science is important? So again, from the basics. So computers are gaining the intelligence for the large amount of the data. So to understand whole data, to give the insights, the basics, machine learning and deep learning are the important things to get into the journey of artificial intelligence. So in within less time, the data is growing rapidly and the industries are looking forward for data insights like data analysis things. So for the day-to-day lives, how the data is impacting, we know already. So it is a high time to understand the data science, to learn data science, and to get career in data science. Yeah, that's it. Thank you guys. And if you have any questions, you can start the Q&A now. Yeah, if you have question and like any questions also, you can ask, or like you can put message in the chat box. I can give you the answer. Yeah, as I said, like career options, you can choose like whether you, if you understand, if you want to understand the deep programming language and machine learning models, you can choose the data scientist. Or like if you say, I don't want to go too much technical, I want something like business as well as like some part of business and technical basics, you can go to data analyst. Where if you say like, I just want slight technical knowledge domain, but I want so much into business, you can go into a business analyst. Yeah. So if you want to start your career in data science, like what you can do is like first you need to get all the hands-on work. Like you should understand the certifications of data science. First, go and start the certification, like understand the machine learning algorithms, work on like Python and do some real projects. Like if you can get the data sets from the Kaggle, or like you have different sources to get the data. So you can take the data and work on it, understand which are the steps, how to do the coding and all these things. If you do in Python or like R or anything, like firstly you should do the certifications help you a lot, and then solving the projects or like understanding the day-to-day updates of the data science, that might help you. So if you are from like any background also, nowadays we can start your career in data science. Just first learn and then do some hands-on experience, then you can. Course, like again, you can speak with Coursevita guys, like they are giving the all the courses, I guess. Still, if you have any questions, also we can wait. Okay. I think Abhishek can give more details about the online course.
Vishwaja, if they follow our pages like LinkedIn, Instagram, they will be getting know all the updates, and we posted our website link as well.
Yes. Thank you. Till if you have any doubts and concepts or like how to start, you can ask here. Yeah, just go through that link. You will understand like which are the courses offered and Coursevita and like what can we do next. Yeah, I think we are good. Like if there are no questions, like we can wind up the session. What do you say, Srinath?
Yes, Vishwaja, I think there is no questions from the students, and I already posted the website link in the chat box. If you go
Yeah.
through our website, they will get to know like what are the courses, and they can fill the career counselor form. Like our career counselor will be contacting once they fill the form.
Okay. So yeah, thank you guys. Thank you all for attending the session. Have a great day.
Thank you, Vishwaja.
Should I leave?
Yes.
Okay. Thank you all.